So let us have an example of solving a problem using analysis of variance. So let's take a look at this problem. Let's just zoom in a little bit. There we go. From each of the 4 suppliers, a quality control technician collects a random sample of 10 rivets, then measures the number of pounds each will withstand before it fails, and use alpha equals 0.01. So I'm guessing what we just need to do is compare whether the 4 suppliers are actually the same or not. So how will we know if this is actually a problem for analysis of variance? So for the problem to be for analysis of variance or Anova, we have to remember that there should be more than 2 groups. Just like what we had before. So here in this example, you can see that we have only 4 groups. Let's just zoom that in. So we have groups for supplier A, B, C, D. So we have 4 groups, but they are groups of the same variable, which is number of pounds a rivet will withstand before it fails. So we would just like to compare whether they are the same or not. Therefore, we will use Anova. So now we can go to our different steps of hypothesis testing. So step 1 is our HO and our HA based on the claim. So our claim, since we just want to compare whether the same or not, is that the same. So based on the problem, we actually didn't see a claim. So what we can just do is assume that the null hypothesis is that the means are equal. So we have to write all 4 though. And then the alternative would be the means are not equal. Now, here, in analysis of variance, there is no direction of the alternative hypothesis. No direction, because we are now already comparing more than 2 groups. So we cannot just simply use these symbols anymore. So now that we have our null and alternative hypothesis, we can now go to our steps 2 and 3. So now we can now go to our data analysis, and here let's just get that closer. So as we can see here, we have actually 3 types of ANOVA. The other 2, ANOVA 2-factor with replication and ANOVA 2-factor without replication, is beyond the scope of our course. So we will just simply use ANOVA single factor. So we selected that already and we click OK. Let's just go up a little bit. And quite different with what we have, we just only have one input range to choose from. But we have to know if it's grouped by columns or by rows. So when we click that, let's zoom out. We have here, they are grouped by column. So I will just select all of them. There we go. Then going back. So they are grouped by columns. So I will select columns. Labels are in the first row. We were asked to use alpha equals 0.01. Output range, let me just select that, and probably I'll select here. There we go. So when everything is set up, we can click OK. So there we go. As you can see, we have 2 tables rather than our usual of 1. So let's take a look at these tables. The first table is actually a summary table of the groups that we have. So we have here the names of the groups, how many are them, when we add them, the mean or the average, and then their variances. These are the variances that actually are computed using analysis of variance. So when we go down, we have actually our analysis of variance table. So what you can see here actually is that we have different values, and explaining them in detail will take a little time, but as you can see, analysis of variance is not anymore T, but we are using actually F distribution, which the explanation is beyond the scope of this course. So, what we will focus on is our p-value of 0.15. So now we can proceed to step 4. So in step 4, using our p-value of 0.15, what is it compared to 0.05? And 0.15 is greater than 0.05, therefore we will not reject HO. Therefore, there is no sufficient evidence to reject HO. So therefore, we can say that the null hypothesis is true, that all the suppliers have equal mean number of pounds before the rivet will fail. So that is one example of how we do analysis of variance in Excel.